Good evening, everyone, and welcome to a nice Eastern California evening. My name is Mike Jerry, and we're going to look at some nebulae this evening. Some pretty red and hopefully blue, and some white stuff, and some very colorful things this evening. So, yeah, so let me first before I do that, let me get this guy open, so I can show you a picture of what I'm going to be using. Okay. It's a few minutes early, I suppose, but I'm ready to go, and the weather is nice. We got a little bit of a breeze here tonight, but it should be really light and intermittent, so enough to keep the mosquitoes away. In any event, here is my setup. Get this. Come on. Get the mouse set up here. Tonight I'm using my trusty C8, an 8-inch Schmidt Cassegrain telescope, and I do have the Hyperstar in the front of it tonight, so the camera and Hyperstar are in the front of the scope, not behind the scope, as it has been for my last few live streams. And yeah, so it is bringing us the images tonight. And I've got an NBZ, an IDAS NBZ filter in here, which is a dual pass filter, which brings through hydrogen alpha, a little hydrogen beta, and oxygen 3, which is what nebulae are mostly comprised of. So it lets nebulae really come through well, but cuts the stars way down, so that we can see these nebulae through all the thick star fields that we're looking at. So, and it's all riding on a ZWO AM5 mount that's swinging it around the sky. So, let's see, and we're going to go to this one. Okay, so here is Vega, which is what I used to check my focus. And so let's bring up my list. And this window is frozen. Wow, boy, you are really, really slow to respond for whatever reason. Highlight all. Close. Okay, here we go. Good. So it looks like we're going to start in the very southern sky. Tonight we're going to try and get, we're going to go for M. We're going to start off with a nice bright shiny start here. With Lagoon and Trifid right off the bat. Now the trick is to get a star central to both, so we can get both in the image. And there we go. That's about almost right. I want to go a little bit further. A little bit further down. I think that's going to be about right. Okay. So let's send the telescope over there. And basically what we're going to do tonight is this is very deep in the southwest sky. We're just going to start low and go higher and higher as all this sets closer to the horizon. We'll work our way higher and higher and higher to try and stay out of a roof line that's in here. That's going to make these things disappear fairly quick. So let's wait for that to get in there, and then, well, you can see Trifid right there. So these are pretty close. And there's Lagoon down there. So it's going to just bring this all whoosh, right up into here. There we go. There's both of them. Okay. So let's get it started. And both of these nebulae are just a few thousand light years away. Let's just leave that there for now. Alright, and I think we will get this out of our way. Okay. Get that out of the way, so that's not going to be bugging us. And we'll have as much screen real estate as possible to see what we want to see. Okay, so let me also get oh, okay, there we are. There's the first one, which is pretty bright. Let's see if this is going to whack out the by. No, look, it's going to do pretty well. Okay, let's get the histogram adjusted to be something sensible. There we go. That's a little bit better. Lagoon and Trifid. Okay. Let's see. A lagoon is, or a Messier 8, the 8th item in Messier's catalog. Mission Nebula, located in Sagittarius. It was discovered by Giovanni Hodierna in 1654. It's one of the only two star-forming regions, nebulae, faintly visible to the naked eye from mid-northern latitudes. The other being the Orion Nebula, which is the middle star in Orion's sword. And so this one is actually visible. This one here on the left is actually visible to the naked eye. It's approximately 5,000 light years away from Earth and is approximately 100 by 50 light years across. So that's a pretty large patch of sky. It appears pink in long exposure photographs, but when, like for what we're doing here, it's going to show up and show its colors. If you're looking at this through a telescope, it's going to be just faint fuzzy. It's going to be gray. You don't see much color through all but the largest of telescopes if you're observing visually. And within this area, you're going to see lots of Bok globules and dark nebula patches and pockets of things in here. And so these are called Bok globules, which are protostar matter. So all of this whole area is an area of star formation. Lots of stars being formed in here. Trifid up here, well, we'll talk about that in a minute. Centrally located Hourglass Nebula. There is an Hourglass Nebula in here. I think I might back the stretch off a little bit, darken this up just a little bit so we can see better, see a little bit more of the structure inside. Turn the background music on here. No, not you. You. Okay. But a couple of really nice nebulae. Let this get a few more sub-exposures in. And so these are right in the south, low in the southwestern sky, low for most people. What are you doing? No, you haven't lost connection. You're fine. So again, very low in the southwestern sky. So this is my horizon here, southern sky, and this is southwest. So just really low in the southern sky, only about 20-25 degrees above. For me down here in Southern California, so for those of you up further north, it's going to be even lower again. Hey, good evening, Jeff from New Jersey. Thanks for coming in. And there's Ron. What's the good word? You know, I've always liked ubiquitous. Somehow that word just sounds cool to me. So when in doubt, that's always a good word for me. How's things with you? This is a very bright object, so keep. What I want to do is actually look in the interior a little bit more, so we can dim this down a bit. Kind of look in the interior here. There's a lot of structure in here. A lot of structure in here, and as we get more subs in, this will get cleaner and cleaner, so something to look forward to here in a little bit. For now, we can just for now we can just look at them sort of as a whole. Brighten it up a little bit more. We're looking at them in macro style. Okay. Then the other guy, the Trifid Nebula, that's in the upper right there. This one was discovered by Charles Messier in 1764. It's called the Trifid Nebula, and its name means three-lobe. The object is an unusual combination of an open cluster of stars, an emission nebula, which is the reddish portion, a reflection nebula, which is the bluish portion, most of which my filter actually kind of blocks out. So it's we don't get a whole lot of the reflection nebula because my filter blocks a lot of that out. Usually there's a lot more blue in here. If we look at it, like looking at this one, I'm only using the UV-IR filter, essentially unfiltered, because then there's a lot more blue in this. It's a great broadband target. So it has the emission nebula, it has the blue reflection nebula that's reflecting the light of stars, and then it also has dark nebulae running through it that creates these sections that when they first discovered it looked like three lobes, and so they called it the Trifid Nebula. I believe it is. Yeah, it's about 4,500 light years away, so it might be a tiny bit closer than Lagoon. But it's a beautiful nebula. Really nice to look at. Broadband. So these two are really nice things to look at. Lagoon is a little bit better with the filter because it blocks out a lot of the star field. And it doesn't have a bunch of reflection nebula that's getting blocked. It's mostly just the emission nebula, the red of the hydrogen and the white of the oxygen. So again, those are the bands of light, the wavelengths that the filter allows through, but it cuts out everything else. So these stars star is a full spectrum emitter, the stars would just be drowning all of this out. And because this filter is blocking out 98% of its light, because it's only letting oxygen-3 and hydrogen through, it makes the stars much smaller. The smallest stars disappear, and the brighter ones become much smaller. So essentially it makes the nebula look like it pops through, makes it brighter, but in reality it's just cutting down the stars and everything else, except the nebula. So it's quite a beautiful nebula. I should say little at 110 by 50 light years across. It's pretty significant. But these dark patches in here are called Bach globules, and they're just dark protostellar matter, stuff that will eventually become stars someday. Beautiful. Reminds me a lot of the Orion Nebula, which we'll be seeing here in the next couple of months. Fall is here and winter's coming. And out here in the desert, we can tell it's fall because the temperatures are just starting to drop under 100. So, where they've been for the last 4 months. So, cool weather is on the way. While these are rolling, see what we're going to see next. I think what we'll do the toe. I like doing the toes in the Chinese dragon broadband. Trifid and those, I like doing broadband. So I think we'll kind of skip those tonight. I see 1284s can be nice. I think we'll just skip right to the big guns. We'll do M17 next. And I like doing all these other targets broadband, just taking the NBZ out, putting a UVIR in, and then just getting all that nice bright blue reflection nebula, which is just really nice on those objects. I think we'll take this. These two are just so beautiful. And they're right next to each other, and you know, I can get them both in my field of view, which is pretty cool. With the Hyperstar, I have just enough field of view that I can get them both. Alright, very nice. Lagoon Intrepid to start us off. And let's get on to M17. Omega Nebula Swan, Horseshoe, Checkmark, or Lobster. Take your pick. I don't think we'll bother plate solving. I think we're going to be pretty darn close. Okay, the Omega Nebula, discovered by Philippe Leroy de Chaussot in 1745. Charles Messier then catalogued it in 1764. It is by some of the richest star fields of the Milky Way, most of which will be cut back by our filter, which is why we're using it. Otherwise the stars just drown it out. It's known by all the names I just said and a few more. Charles Messier put it in his catalog as item number 17. This is between 5 and 6,000 light years away, and it's only 15 light years in diameter, as opposed to 100 by 50, which is how big the lagoon was. So this one's fairly svelte in comparison. Fairly small in comparison. We have 1.1, 1.2. Kick it up a little more. It spans some 50 light years in diameter. The cloud of interstellar matter of which this nebula is a part is about 40 light years in diameter. Considered one of the brightest and most massive star-forming regions in our galaxy. Its local geometry is similar to the Orion Nebula, except that it's viewed edge-on rather than face-on. So we're kind of looking at the edge of this, and with the Orion Nebula we're looking at it pretty much face-on, which is why the Orion Nebula looks so much bigger and brighter to our eyes. This one we're just kind of looking at the edge of. Looks like we're got a little bit of a breeze, so the guiding is a little bit wonky, but it's doing okay. I like its little sub-nebula up here. It looks like sort of a bat body there, and the wings kind of going up and over. Or a big bird of some kind. But that's not the Eagle Nebula. The Eagle Nebula is above this, and we're going to go see that next. The open cluster NGC 6618 lies embedded in the nebulosity and causes the gases of the nebula to shine due to radiation from these hot young stars. However, the actual number of stars in the nebula is much higher, up to 800, 100 of which are spectral type earlier than B9. 9, blah, 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 blah. Plus, there's over 1,000 stars in formation on its outer regions. It's also one of the youngest clusters known, with an age of just 1 million years. They're all making it glow. Up a bit so we can see a little more. Hey, good evening, Ray. Good, I'm glad you got the Sea Star out. They're a lot of fun to play with. I got friends who own some, so I know they're pretty cool things to use, and they get some pretty darn good images too. For what they are, they get really good images. Same setup as last time, Ray. The filter I'm using is an IDAS-NBZ. So it's a 12 nanometer dual pass filter, passing oxygen 3 and hydrogen alpha and a little beta, I think. Zoom in a little on this guy. Get a little more look at the detail. Kind of like this guy up here too. This whole area here has got some interesting stuff going on. I like its shape. Yeah, it looks like some sort of winged creature with a big wing here and body there and the wing here. Like a dragon maybe. Don't know. It's kind of cool though. Good evening, Mike. How are things? Welcome to the broadcast. As you can tell, we're working on M17 here. Oh, hey, Allie. I'm glad Una's tuned in, too. I'm sure she's just loving this astronomy stuff. Good to see you. So this is M17, the Swan Nebula, or Omega Nebula, or Checkmark, or what are all the names? This thing's got more names. Checkmark, Lobster, Horseshoe, Swan. And I guess everybody had an opinion on what this thing looked like back when they were looking at it just through telescopes and could only see a fraction of what we see today. If we kind of unstretch this a bit, you see maybe what they kind of saw back then, although not even nearly this much. So what they saw was just the neck of the swan here, and the body of the swan kind of gliding along the water. They didn't really see all this extra stuff. We didn't really get to see that stuff until we had telescopes and cameras and things that could see more of this. But when they were looking at it through telescopes, they saw basically this brightest part, and that's about it. So I could call it the swan. But now we've got modern digital cameras, and we can see a whole lot more. And so now it doesn't look like. Sometimes these nebulae don't often look like what they were named. Una's my biggest fan. Oh, well, isn't she sweet? Cool. Alright, well, there is the Omega Nebula. So, let's go up and look at the Eagle Nebula next. I don't know why this keeps losing connection to my camera. Maybe I'll try reseating the connection while we're slewing up to M16 here. Okay. Alright, we'll see if that gives me less grief. Alright, so we should be centered on that. Yeah, you can see it right in there. So let's start imaging. Okay, while that's doing that, there's a 16, not 16Y, just 16, also called the Eagle Nebula. It's another open cluster of stars. This one was discovered by Jean-Philippe de Choiseul in 1745 and 46, or somewhere in that range. Both the Eagle and the Star Queen, it's also called the Star Queen Nebula, refer to visual impressions of the dark silhouette near the center of the nebula, an area made famous as the Pillars of Creation imaged by the Hubble Space Telescope. Right, which is this little area right in there. And we'll take a look at that in a bit once we have gotten a few sub-exposures in, which will allow things to sharpen up a little bit. saturation a little bit. The rest of it's probably going to be okay. Alright. What else do we know about it? Well, so we'll look at the pillars here in a few minutes. Once we've gotten some, a few more sub-exposures in. It's an emission nebula, which is about 5,700 light years away. A spire of gas that can be seen coming off the nebula in the northeastern part. So, it's probably this. It's approximately 9.5 light years, or about 90 trillion kilometers long. The cluster associated with the nebula has approximately 8,100 stars in it, which are mostly concentrated in a gap in the molecular cloud to the northwest of the pillars. The brightest star has an apparent magnitude of 8.25. That star has a mass of about 80 times the size of the Sun and a luminosity of up to 1 million times that of our Sun. 1 million times as bright as our Sun. That's unimaginable. bit of a gap till we head up to here, which I think is the cloud sculpting. Yes, star. Cloud sculpting star cluster. Not as big and bright as these are, but still a pretty cool nebula. We got us a few subs in, so let's turn things down a little. Turn down the heat a wee bit and head in and see the pillars. So we turn this down and we head right on in here to what we see, this sort of bird shape, eagle shape. This is why it was called the Eagle Nebula, is because of this guy here. And what the Hubble Space Telescope really showed us a few years ago was that these are all the pillars. These are like pillars of dark gas, and this whole thing is a star-forming region, so it's where stars are created. So they got dubbed the Pillars of Creation. See, this third one here is very light, but it's there. Pillars. Zoom in a little bit more. Why not? Some people think this is a dinosaur holding a baby dinosaur. Nebulae are, well, they're just like the clouds in our own sky. Look at them and everybody has a different idea for what the shapes are. But those are the pillars, the three pillars, 1, 2, and this one here is another one as well. It's just a little bit lighter in color. But pretty interesting constellation. And when it's turned down like this, you can kind of see the eagle a little bit better. And it It's also called the Star Queen because this looks like the Star Queen in silhouette. I don't know what the Star Queen is, but apparently that looks like it. So there you are. There's the pillars. And then we can brighten it back up again so we can see everything. There's a lot of stuff on the outsides too. Stuff out here that doesn't get a lot of notoriety. A lot of cool looking gas and dust out here. Forming stars at some point. This whole area is all star formation in here. The whole area down here between Sag and Scorpio. Now we're going to go to another one. So let's head on up, continue heading up the sky. Summer constellations that are out there. So that's kind of okay. Let's head up the sky a bit more. Alright. And we'll play it soft to make sure it's in the middle. It's off by a little. Alright, and then we'll go. This whole area is part of a Sharpless object. The Sharpless catalog is a catalog that was made of emission nebulae. So mostly the red emission nebulae that we're seeing in a lot of these, most of what we're going to see tonight, are in the Sharpless catalog. Okay, let's move you out here. We'll give this a few sub-exposures to catch up. Hey, good evening, Joe. Thanks for tuning in. We're just started on the Cloud Sculpting Star Cluster, which is this open cluster of stars that's also associated with this emission nebula right here. the open cluster, which is this little, oh, we can just pull up the annotation and see it for sure. But it's going to be, I'm pretty sure it's this cluster here. Yeah. So this cluster of stars here is about 50 light years across and lies about 6,000 light years away from us. Center of the cluster. Why is it an open cluster? It's an awful small open cluster, huh? The center of the cluster formed about 2 million years ago and is dominated in brightness by a host of bright young blue stars. Hey, welcome, Ollie. Good to have you here. We're working on the cloud sculpting star cluster right now, which is this star cluster, and the emission nebula it seems to be powering. Causing to fluoresce. I agree, star clusters are nice, especially when they are accompanied by some nice nebulosity, which they are causing to fluoresce and emit its own light. So, pretty cool. This one's a bit dimmer than the ones we've been doing up to this point, but got a lot of character. Lots of dark nebula in here, and even some Bach globules again, just these little spots of dark protostellar matter. good if you can spend some time. The tulip. The tulip is small, but it's a pretty cool one. Sharpless 101. The tulip. Yeah, we'll get that guy next. Cloud sculpting star cluster. Okay, let's go do the tulip next. Continue to head up sky here. Getting closer and closer to the meridian. Alright. Probably gonna be pretty close, but we'll make sure it's dead on. As you can probably hear in the microphone, it's got a little bit breezy. So the guiding is not great, but it's not really affecting our images much, so. Not a big deal. Alright. Let's see if Wikipedia has something on the tulip. Yep, it does. Actually has it listed under its Sharpless 101 number. Again, Sharpless 101 is a Sharpless catalog is a catalog of emission nebulae. It's sometimes called the Tulip Nebula because of its outline. It appears to be a tulip when imaged photographically. It was catalogued by astronomer Stuart Sharpless in his 1959 catalog of nebulae. It also is about 6,000 light years away. So you can see how it's kind of got a bit of a tulip shape to it. And you can also see how many stars there are here. I mean, look at how it's almost being drowned out by all these stars. And this is with a nebula filter that is cutting down 98% of the light of the stars. So you can imagine without the filter how hard it would be to see this. Nice nebulosity down here too. But this is the tulip. This is what we're after here. You know, we were right next to the dumbbell. I would appreciate it. No, I don't know that I've ever shot the dumbbell with these filters, so we'll give that a try next. Kind of change gears just a little bit and do a planetary nebula. See how it comes out with the nebula filters. Probably will come out okay, now that I think about it. Definitely looking tulip-like now. There's a whole lot of nebulosity in this region at the bottom of Cygnus. Cygnus of the Northern Cross, which right now is up near our meridian, which is the red line here. So the very top of the sky. But all this is a lot of nebula, not a lot of nebulosity in here. I guess actually we could, at this point we could zoom in a bit. Get a nice area of mostly red hydrogen, a little bit of white oxygen, and dark areas of dark nebula going through it as well. Very nice. Okay, let's go try and do something a little bit different. Let's go try doing a planetary nebula. Let's back down the sky a little bit, but not that far. The Dumbbell or Apple Core Nebula. You can see it right there. It's going to be pretty bright. In fact, I probably don't even need to use $60 seconds on it. Do I have 30 seconds in here? Remember if I've got a dark on? No, I don't have a dark on it. Oh well. Never mind. Go back to the 1 minute. Alright. Clear that. It's a planetary nebula we're going to do next, which is basically a star, a main sequence star like our Sun, that is in its death process. It's burned out most of its fuel, and which makes the core of the star a lot lighter because it's burned away most of its fuel, and so its outer layers start expanding. There's not enough gravity to hold them together, to hold them in anymore, because when a star burns, it is a constant balance of the the nuclear furnace that is blowing solar wind and radiation out from the core of the star, and the intense gravity that's holding the star all together, sucking everything in. And when a star like ours gets near the end of its life, it burns away most of its fuel, and the core essentially gets lighter, and so the lack of gravity actually causes the outer layers of the star to whoops, wrong button. The outer layers of the star to leave. Essentially, the star just expands as it blows off its outer layers, and as it does that, it leaves behind its a much dimmer core, which eventually can turn into a brown dwarf. And so the core is still burning. It is still bright, and it is still burning. It's just not nearly as bright or hot as it was when it was a whole star. But it's enough to illuminate the expanding cloud of gas, the expanding shell of gas that the star is blowing off. And so it creates this colored blob area. Sometimes it's a ball shaped, sometimes it's, no, this is an hourglass or apple core shape. So this is sometimes called the dumbbell or apple core nebula. And so this is the star that's blowing off its outer layers and illuminating them as they go. And so it's a star that is basically in its death process. It's kind of going to be ending its life over a few million years. And so, yeah, I forget what I was going to say there, but yeah, this will be what our sun is going to do in about a few billion years. We got a little time yet, but when they first discovered these, they couldn't. They didn't really know what they were. They had very they had telescopes that weren't very powerful, and so they couldn't really see. They couldn't really see them anywhere near as big as this. And so what they saw was just these, these little tiny, these little tiny blobs that looked like planets, because they knew they were too big to be stars. They knew they knew they weren't point sources. They weren't stars. They were bigger than stars, and they could see color in them, just very faintly. So they thought they were planets. And so they called them planetary nebulae, because they just weren't sure what they were. And the name is kind of stuck, even though we know now that they have nothing to do with planets. They're actually stars. The name is stuck, and they're still called planetary nebulae. But this one, sometimes when the gas, the outer layers of the star blow off, they are affected by the magnetic field of the star itself, and so that's why this has sort of a shape where most of the illumination is along the magnetic field of this star. So it has this apple core or hourglass shape, mostly, and less so on the sides. So, but it's a very interesting. It's a sort of a beautiful way to die, I guess. And as you can see, they're very bright because they're being illuminated by a star that's very close to them. It's right at the very center of them. But I'm zoomed in way more than I probably should be. but yeah, that works. Oh, Amargosa Valley native, huh? Well, thanks for checking in, Michael. Yeah, I know where Amargosa Valley is. Well, I guess actually, technically, I live in Amargosa Valley, but I know where the town of Amargosa Valley is. In fact, I drove up there a week ago yesterday when the Ponderosa Dairy had a... I'm on the local fire department here, and the Ponderosa was burning something or had a fire or something, and we were called up to help out and then called off. So, drove up into that almost Amargosa Valley itself when we went up there last week. So, yeah. Boy, my guiding is going absolutely crazy. I don't know why. Keeps losing connection to the camera. Don't know why that's happening either. Well, the images are coming out okay. The stars are slightly ovally, but it's getting the job done. They are beautiful, though. These planetary nebulae really are some interesting. Can be some really. Some of them are just like round, but some of them can be really wild and interesting colors. So this one's got a lot of blue, obviously, but it's got some red as well. You can just sort of faintly see the central star. I should also say that most planetary nebulae are very small. They're usually pretty far away, and they're pretty small as a result. You know, they may be a light year or two across, but when they're a few thousand light years away, they're not very big. Most of them aren't much bigger than stars, which is how they fooled people into thinking they were planets. But this one is one of the largest and closest to us. I think it's just a couple of thousand light years away. In fact, maybe less than that. Actually, less than 1,000. I don't know. Let's see where. Why guess? Let's just look it up. See where it is. If I can type. The constellation Bortle. It's about 1,350 light years away. So it's one of the closest and brightest. It's a good binocular target. I think it's about 14 or so thousand years old. Or maybe 10,000. 10,000 years old. Central region marked by a pattern. It certainly is a pretty one. Oh yes, definitely go out and look for yourself, Ollie. I mean, you can always come back and see the recording of this later. So yeah, if you have the opportunity to go out. Right now here in Southern California, we're having a pretty nice night. So go out and definitely take advantage. Would never discourage anybody from going out and looking up at the stars themselves rather than watching my stream. Because, you know, watching a live stream of this stuff is nice, but getting out under the stars and collecting some photons in your own eyes is even a better thing. Sort of a reddish pinkish texture on the outside. Some nice blue on the inside. I think if we stretch it, there's a little more to it, but let's do this. And do it. Whoops, wrong button again. I think if we stretch it, there's a little bit more to the outside of this. Yeah, there's a little bit more stuff out here, but then of course we blow out the core. But you can see sort of this almost jet-like material coming off here. So this kind of this hourglass shape of material in here. But it blows out the core, so we can't really see the middle stuff, which is really interesting stuff. So back the stretch off and take one more sub here and call it a day. Really is a beautiful night though tonight. Really is a beautiful night. We're getting a little breezes here and there, but they're pretty light. Other than that, it's just a really nice, clear, calm night. So the transparency is actually better than expected, given that we just had the remnants of Hurricane Mario move through on Thursday and a little bit of Friday. But cleared out pretty well, and yeah, left a bit humid, but not so bad. All right, so what were we gonna do here? So we were, before we got distracted on this fun thing, so now we're gonna go do the crescent. Which is a good one. And I think I want to get a little more than... We'll get the crescent and we'll get a little bit of the solder region here. Some interesting, cool nebulosity. We did the crescent the other night on my last stream, but it's such a great object that it's worth doing again. Alright, let's go do that. Let's go do it. Get you in there. And plate saw view. Do a little bit of a flip. Okay. Alright. So that was a nice little distraction on something different. We're going to see a lot of emission nebulae tonight, but that's nice to pop over and do a planetary nebula. All right. Let's look up present nebula. So we're doing now an emission nebula in Cygnus. It's about 5,000 light years away from Earth. Discovered by William Herschel in 1792. It's formed by fast stellar wind from a Wolf-Rayet star, which is basically a super hot, super luminous star. Like many times the brightness, the luminosity of our sun. Just a super powerful star. Oh, and you're gonna do this blue going nuts thing again, huh? Yeah, we'll see about that. There's the Crescent Nebula and a little bit of some of that nebulosity from the solder region that we're gonna look at. This is caused by a Wolf-Rayet star, basically, which blew off some of its outer layers, similar to the planetary nebulas that we've been talking about, and then became just super hot and super luminous. And so its stellar wind that it is now creating is faster and more powerful than the initial blow-off, and so it's illuminating all of it and turning it into a big old shock wave, basically. Ow! So it's formed by the fast stellar wind from the Wolf-Rayet star WR136, colliding with and energizing the slower moving wind ejected by the star when it became a red giant 250 to 400,000 years ago. The result of the collision is a shell and two shock waves, one moving outward and one moving inward. The inward moving shock wave heats the stellar wind to X-ray emitting temperatures. Most telescopes or binoculars would require an oxygen-3 filter to see it. We'll which is why it's a lot of white. There is some red in it, but it's mostly white, mostly oxygen. Under favorable circumstances, a telescope as small as 8 centimeters with a filter can see its nebulosity. Larger telescopes reveal the crescent or Eurosine shape, which makes some call it the Eurosine nebula. Stretch it up a bit now. That's coming along very nicely. This outer region is a bit interesting. We can do the Pelican Nebula next. I think that's 5067. That's about right. We'll do that. I really like the crescent. Comes out pretty nice. And again, the RA axis goes absolutely, the RA axis goes absolutely. No, the deck axis goes nuts. I have no idea why. Whoops, that's not what I meant to do. That is. Such a cool object. Okay. The Crescent, or Ear Nebula, or Eurosign Nebula. Beautiful object. Created by a very powerful star. Alright, so now we're going to go up into the Pelican Nebula. Thank you for the thumbs up, everyone. I just noticed that's you guys gave me a bunch of thumbs ups. Thank you. I appreciate that. There is. Pelican Nebula. It's associated with the North American Nebula. Oh, look at that. It's centered perfectly. Reminds me of a bunny rabbit. I mean, this is the eyes, the nose, the ears. This looks like a bunny rabbit to me. I don't know about the pelican thing, but whatever. It's right next to the North American Nebula, which, if you look in the Planetarium, there's a North American Nebula right there. And the pelican is right here. Right at the very top, there's Deneb right there, which is the very top of the Northern Cross, which for those of us who are in the Northern Hemisphere, you can look, well, on the West Coast, you can look pretty much straight up right now. There's the meridian, so it's almost straight up. For you guys in the Eastern more time zones, it's going to be a lot lower in the sky, but it's, this whole area's got a lot of nebulosity. The Pelican is located nearby the first magnitude star Deneb, yep, and is divided from its more prominent neighbor, the North American Nebula, by a foreground molecular cloud filled with dark dust. Yeah, so basically this is the very edge of the North American Nebula here, and this is the molecular cloud here, so it's all kind of blocking the light, basically. Pelican is much studied because it has a peculiarly active mix of star formation and evolving gas clouds. The light from young energetic stars is slowly transforming cold gas to hot and causing an ionization front gradually to advance outward. Particularly dense filaments of cold gas are seen to still remain, and among these are found two jets emitted from the Hyperstar object 555. Millions of years from now, this nebula might no longer be known as the Pelican, as the balance and placement of stars and gas will leave something that appears completely different. So it's constantly changing, in other words. Go figure. is coming along nicely. Yeah, North American. The problem with North American is it's too big. I can get sort of a kind of a piece of it. But it's just too big. So yeah, I'm gonna skip it. What else have we got? Oh, the cocoon. Have you crossed yet? Oh, no. You crossed the meridian yet? Yes, you have. The cocoon is a nice one. Although it's better. Well, it's got a lot of reflection in it, but it's still a nice one. So we'll go to the cocoon. Let's go do the cocoon. Na, 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 na. Alright, go on you. Get on in there. There you go. Oh, it should be close enough. Oh, no, 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 not you. Wrong one. This one. Should get rid of those other ones. Stretch off a bit. Yeah, this is a lot of reflection nebula. So it'll have a little bit of blue, but a lot of the reflection nebulosity won't be there, but the dark nebula will be. So it's another one kind of like the Trifid that we started off the night with. It's got all three forms of nebulosity in it: emission, reflection, and dark. And whoa. Wow. That's very interesting. Why are we not tracking? Where is... It says it's tracking. Why are we not tracking? What the heck is going on here? Start this again. Okay, something is very wrong here. I'm not sure what. Let's start over again. Maybe I interrupted the process. Let's re-slew to the object. Maybe in interrupting the process, because I emergency stopped this the wrong sequence partway through, and so it may have messed up the sequence. And this is now going nutty again. Okay. Start over again. And unfortunately, the dark nebula trail is going this way. Yeah, it is just going off. So my orientation isn't great. In fact, what I'd like to do is plate solve again. Okay, it doesn't want to do that. Okay, so now let's try doing this. Put the center somewhere down here. Okay, and so then it's going to, this is going to complain again because I just moved it without getting the permission of the guider. Alright, so now, not that, I'm going to turn this off. Okay, so sorry for the technical difficulties here. One little mistake and you're thrown off the rails for a few minutes. But that's what happens when you're dealing with a lot of complex software and equipment all working hopefully in harmony. But sometimes when one thing goes out, takes a whole bunch of other stuff with it. Yeah, this is behaving more or less normally now. Oh, and I just blew this. Okay. Kill this. We'll have to look at a blank screen for a few minutes, or for a minute, but I keep missing the window there. So just gonna have to wait. Anyway, let's hear about the Cocoon Nebula. It's a cluster of stars involved in a bright and dark nebula. The cluster is also known as Colony 470. It's about 4,000 light years away, and the central star that lights it formed about 100,000 years ago, which means it's very young. The nebula is about 12 arc minutes across, which comes to a span of about 15 light years across. When viewing it, the dark nebula, which is this trail coming off it, which is why I moved it up in the image, because this really is a critical part of viewing it. It's really a cool part of it. Yeah, so this dark nebula here. Now, this nebula itself has got a lot of blue fringing on it. It's got a lot of reflection nebula. Unfortunately, my nebula filter, because reflection nebula is reflected starlight, which is full spectrum, in the same way it blocks 98% of the stars and keeps them from flooding the object out, it also blocks 98% of the blue reflection nebula. So this object is actually better to do without a filter, but it's still pretty cool even with it. So we'll spend a couple of minutes on it. But it is a stellar nursery, and the bright star at the center of it that's illuminating all of it is only about 100,000 years old, which is very, very young for a star. Observations by both the Spitzer Space Telescope and the Chandra X-ray Observatory have collectively identified hundreds of young stellar objects. Young stars are seen in both the emission nebula, where gas has been ionized by massive young stars, and in the infrared dark molecular cloud that forms the tail, one of the most massive stars in the region. Is estimated to be 15 to 17 times the mass of our Sun. So that's interesting. Young stars are seen in both the emission nebula, where gas has been ionized, and in the infrared dark molecular cloud that forms the tail. So there's young stars in here and all in here as well. So, that's pretty cool. portion of elephant trunk. Again, it's like North American, it's too big, but it's got some interesting structure in it, so might be a good way to go. Misty clover cluster. Could be a good way to go. Oh, we got satellite blazed through. That's alright. The cocoon. Very interesting nebula. And again, better without the filters, because then you get a lot more of the blue reflection nebula. There's a lot more color in it. But still a pretty cool object, even with the filter. So, let's send us over to the elephant trunk. Lots of interesting structure in the sky. I'll do a plate solve anyway, just 0.3, we're off by a little. Alright. Let's go. This one is mostly straight emission, so this one should work out pretty well. This doesn't have an NGC number, really? Huh. That's interesting. Elephant's Trunk Nebula. There's a concentration of interstellar gas and dust within a much larger ionized gas region. It's about 2,400 light years away from Earth, so much closer to us than what we've been seeing so far. Let's see what you're gonna do. Yeah, you're just gonna go nutty with the blue, which you seem to like to do for whatever reason. Dark, dense globule that gets its name from its appearance in visible light wavelengths, where there is a dark patch with a bright, sinuous rim. The bright rim is the surface of the dense cloud that is being illuminated by ionized by a very bright, massive, multiple star that is just east of the Elephant's Trunk Nebula. The entire region is ionized by the massive star except for the dense globules that can protect themselves from the star's harsh ultraviolet rays. The Elephant's Trunk Nebula is now thought to be a site of star formation containing several very young, less than 100,000 years old, stars that were discovered in infrared images in 2003. Two older but still young, a couple of million years. stars are present in a small circular cavity in the head of the globule. The combined action of the light from the massive star ionizing and compressing the rim of the cloud, and the wind from the young star's shifting gas from the center outward, led to very high compression in the Elephant's Trunk Nebula. This pressure has triggered the current generation of protostars. Alright, are you ready to behave yet? Yeah, I think you are. Yeah, so kind of an interesting portion of it. Give it a little more red, please. Give it a bit more red. A lot of oxygen in it too. There's a lot of white. It's kind of cool seeing it all in one thing, but this works. Clouds of gas and dust. We're going to do another couple of minutes on this, and then I'm going to go do a bonus object. The Lion Nebula, which is a challenging one to get. It's a challenging one because it's very faint. So we'll spend a little time, but this will be our last one of the night. So we'll just spend a little time on that and see how much of it we can pull in. I'll go to 10 minutes on this one, and then we'll go over there and spend a little, at least 15 minutes on that one, see if we can, how much of it we can pull in. Fact, I think what I'm going to do on that one is I'm going to go to 3-minute sub-exposures. Rather than 1-minute jobbers like I've been doing now, for that one we're going to switch and do 3s because it's a very faint one. It's a nice one, but it's a faint one, so that will be next here as soon as I finish. This sub will go over there and get that one, and that will be the last one for the night. Recentered it a little bit. Didn't quite come in as good as I hoped, so I just wanted to recenter it there and bring it down a little bit into the field of view a bit better. So hopefully that we succeeded in doing that. And that object's center is considered, but there's a bunch of blue stuff off it that is part of it. It's way off the side, so it doesn't actually bring the whole object into the center. So I have to kind of manually reposition it a little bit. Okay, that did not work. Why did that go in the wrong direction? I need to bring it down. Center needs to be like... Okay. Just have to redo this all over again. Okay, we'll do this. We'll start it all over again. Oh, wait. Oh, I think I know why it's doing this. I think because oh. Actually, no, actually that's not. Ah! No, not that. Oh, this is just bizarre. Now it's going in completely the wrong direction. Why? Okay, this is totally not working. I hate when software doesn't work correctly. So this function is working in the opposite of the way it's supposed to work. So I need to start all over again. I'm going to cheat and do this. We're going to re-slew to this spot, which is probably going to be too much. Let's go try that one. That's probably too much. Let's try that one. That's probably going to be about right. Okay, let's try that. Hopefully this will work. Side like that. Okay. I'm not sure why this is happening. It's not centering correctly. So that direction. So, to do that, I'm supposed to be able to do this. And then if you move this here, I'll put the center there, moving everything else off to the side. And it did it. See what happens. Turn the tool off. It seemed to be doing what it's supposed to do. Kind of frustrating when you have to wait 60 seconds between every single frame, every single move, every single transform you do, whatever the word is I'm trying to find. And you have to wait 60 seconds to know if it worked. I thought it was going to be a challenge to image this object. It's just a challenge to get it in the field of view, and I don't know why. It should not be this difficult. Sticking with it. It's not exactly the way I want it, but I'll be here all night trying to frame this stupid thing. I really like it down further, but I can't seem to make that happen, and I don't know why. So what? Not like I got anything else going on. So, move these stars down like that. So, to do that, I should be able to do this. And that, and I should move these stars right down here. And it didn't. It moved them in the opposite direction. It moved them this way and up, which it's not supposed to do. I have to move these down. So why is this happening? If I put this up here, it should move these down. So I should move these down. It moved them up and off the image. See if this moves it back down again. This is just wacky. It's for some reason it is operating in the mirror of the way it is supposed to work. Okay, what am I trying to do? Usually that pixel position recenter tool works pretty well, but every once in a while, for some reason, this happens. one of the directions starts working the opposite of the way it's supposed to work. I have no idea where the heck is going to come out now. almost 15 minutes on it. I think that came out pretty well, all things considered. Given my struggles trying to make the thing center in the field of view, but oh well. I think it came out pretty well anyway. So, anyway, I'm going to call it a night. Thanks everybody for joining. Hope you got to see something you liked.